Hi everyone, welcome to video number 4 of the 2023 Mathema summer session. Today's topic is all about circles, my personal favorite shape, and also something I'm pretty good at drawing freehand. And here is what I like to call the anatomy of a circle. So here are a few terms that you're going to have to be familiar with when working with circles. First off, the center is just a point at the center of a circle. And something special about circles is that every point on the edge is an equal distance away from the center. And that's what gives the circle infinite lines of symmetry. Okay, and what we call the outside edge is the circumference. So this is kind of like the perimeter of a square, but when we find the perimeter of a circle, we call it the circumference. And we'll figure out how to find that exactly later. Okay, and a chord is a line segment that connects any 2 points on the circumference of a circle. So for instance, connecting there to there. And one very special chord is called the diameter because it is the largest possible chord. It runs through the center of a circle. 1/2 of the diameter is a length called the radius, as seen here. This is one of infinite numbers of radii that you can find in a circle. And a radius is simply the distance between the center to the edge. And finally, one more thing, the tangent line is a line that kind of touches the outside of a circle at exactly 1 point. And one special property is that the tangent point, and the radius form a right angle, which can be very useful when solving a lot of different problems. All right, here are 2 of the most important calculations you'll see regarding circles. So first of all, I'd like to define pi, spelled Pi, and it has this little symbol right here. Pi is an irrational number, and it is roughly 3.1415. You can remember it as 3.14. And it is the ratio of a circle's diameter. Sorry, it is the ratio of a circle's circumference to its diameter. And it's a very important number because we're going to use it when we're calculating the circle's area and the circle's circumference. So first of all, for the area, it is pi times the radius squared. So quickly, if the radius of a circle is 4, what is the area? The area would be 16 pi. And you can multiply 16 times 3.14, but a lot of times in competition math, they'll ask you to just write your answer in terms of pi. So that'd be 16 pi. And for the circumference, the equation is 2 pi r. Or you might notice that this is the same thing as pi times the diameter. So if the radius of our circle was 4, what is the circumference? The circumference would be 8 pi. All right, one more question. Say that you have a pizza and the diameter of your pizza is 12 inches. Your friend also has a pizza, but the diameter of their pizza is 10 inches. Calculate how much greater the area of your pizza is compared to your friend's. And when you get the answer, put it down in the comments. All right, here are 2 more need-to-know concepts. So first we have a circle sector. That is this right here. It's like, think of it as a slice of pie. And what you'll often see is that you'll be asked to calculate the area of the sector. So if you know the angle measure of the sector, then you can calculate the area quite easily. You also need to know the radius of the circle. So to solve for the area of the sector, what you need to do is set up a proportion. You can see I've set it up at the bottom where we have the angle of the sector, 55 degrees, over the total degrees in our circle, 360 degrees. And we set that equal to the area of the sector divided by the total area of the circle. So here we've given to you the radius of the circle is 10. So you can work this out on your own to try to calculate the area of the sector. And if you want, put your answer in the comments. and we'll let you know if you're correct. All right, and the arc is something quite similar, but it is essentially a section of the circle's circumference. So for example, this arc is just right here. It's a minor arc. And you kind of do something similar, this time with circumference. So you set up a proportion with the degrees in the arc divided by the total degrees in a circle, and set that equal to the arc length over the circumference. So given that the radius is 10, you can also find the circumference and also find the arc length. And feel free to put your answer in the comments below. All right, so here is your challenge problem. We have here a lovely picture of a fish monster. Just kidding. So ignore these details when you're doing the problem. Those are just for fun. The actual problem is here. So you have a semicircle with a radius of 14, as well as a quarter circle with a radius of 14 too. And you have a smaller circle inside the semicircle with a diameter of 8. So the question asks you to find the area of the shaded sections. And you can see that everything is shaded except for this small circle. Ignore this, as I said. So pause the video here and give it your best shot. All right, so let's work through this problem together. First of all, I said that this was a semicircle and a quarter circle separately to try to trip you up, but really you can just consider this as 3/4 of a circle. So what you would do is you would find the area of a circle with a radius of 14 and then multiply that by 3/4. So let's do that. The area of a circle, the formula is pi r squared. So we're going to do pi times 14 squared. Now that gets us 196 pi. But remember, we have to multiply by 3/4 because we have half of a circle here, or 2/4, plus another fourth of the circle. So it's essentially 3/4 of the circle. Now 196 times 3/4 is 147 pi. All right, but we can't forget to account for this little part, kind of the eyeball. That part's not shaded, so we have to subtract it from 147 to get the area of the shaded section. So to do that, let's find the area of this eyeball. Now, I said earlier that the diameter was 8. So don't be tripped up. Remember, you have to find the radius for the area of a circle. And the radius of the circle would be 4 because the radius is 1/2 the diameter. So now the area would be pi times 4 squared, or 16 pi. All right, now we have to do 147 pi minus 16 pi, which gets us 131 pi. And that is our answer. 131 pi units squared is the area of the shaded section of this shape. All right, if you have any questions, feel free to leave them in the comments. I hope you learned something today, and I hope you enjoyed this lesson. Thanks for tuning in.